This video will cover problems 1, 2, 3, and 4 for the Chapter 2 section of your final exam review. 1 and 2 are all about transformations of quadratic functions. And so just reviewing this real quick might be helpful. We talked about what happens to a function based on what kind of transformation is happening. So remember, you could have shifts, right? Anything that is vertical, so for example, a vertical shift, that is happening outside the function. Or a lot of you like to help remember that that's going to be outside of any parentheses you might see. So if you're going up, you're adding that number on at the end of the function. If you're going down, you're subtracting that on the outside. Now, if you're shifting horizontally, remember you're going to be adding or subtracting inside the function, inside your parentheses. And remember, this is opposite what you would think. Anything horizontal is opposite what you would naturally think. So if you're shifting left, you're adding. If you're shifting right, you're subtracting. We talked about if you are reflecting or flipping your function. If you're flipping vertically, right, over the x-axis, that negative will go on the outside of your function. If you're reflecting horizontally across the y-axis, that negative will be inside the function. You can also stretch and shrink. So remember, when you stretch or shrink, you're multiplying by that factor. And if it's a vertical stretch or shrink, that's happening outside the function. And then remember that horizontal stretch or shrink happens inside, and it's kind of opposite what you would think, right? So if the number is greater than 1, that's a shrink. So let's apply this to 1 and 2 in our final exam review. In number 1, it says let the graph of G be a translation, so a shift, 2 units up and 4 units left. Okay? And that's the only thing that's happening. And they give us the original function f of x, and we need to write the new function g. So I know that if I shift up, I'm going to be adding 2 onto the outside of my function. And if I'm shifting 4 units left, that's a horizontal shift, and that's going to be opposite. So since it's left, I'm going to add 4 on the inside of my function. So if I'm using f of x, this is kind of the setup I'll have. Inside the function, or inside the parentheses, I'm going to be adding 4, right? That's the opposite of what we think. So I'm going to be adding 4, and I still have this plus 2 here. And on the outside of my function, I'm going to be adding 2 because I'm shifting up. Okay? So this plus 4 on the inside of the function came from the horizontal shift left, and this plus 2 came from the vertical shift up. Now I'm just going to simplify this. Okay? So on the inside of my parentheses, 4 and 2 add up to 6. So I'll have x plus 6 squared, and then negative 1 plus 2 simplifies to positive 1. So that is my function there. In number 2, we're doing a vertical stretch of 3. Okay, so this is exactly what you would think. Your a value that you're going to multiply by is 3. And that's going to happen on the outside of your function. So in front of the parentheses, we're going to have a reflection on the x-axis. So that's a vertical reflection. So that's going to happen on the outside. And a translation 2 units up. So that's a vertical translation up. So you're going to be adding 2 on the outside. This is all going to be stuff that's happening outside the function. So my original function is f of x equals x squared. So g of x will be equal to, remember, we're going to have a reflection and a vertical stretch. So there's going to be a negative on the outside from the reflection and the vertical stretch of 3. We're multiplying by 3. Okay. X squared, and then we're going to add 2 on the end for that translation up. All right, and number 3 and 4, we are given a quadratic function in standard form, and we need to rewrite it in vertex form. So I reminded us here, you'll have this formula on the exam, but here's our formula in vertex form. So in order to write something in vertex form, we need to find the vertex. So I just made a rough sketch of this parabola here, and remember the vertex is the minimum or the maximum, and HK is the point of the vertex, the x and the y coordinate of our vertex. In order to find this vertex, we first have to find the x value of our vertex. In order to do this, we need to remember that this axis of symmetry goes through the vertex. And we have a formula for the axis of symmetry, and I wrote it over here. It will be provided to you on the exam. This will provide us with the x value of our vertex. And so remember, to find my a and b value, I need to look at my coefficients. So a is 1, b is 2, and c is -3. I'm going to go ahead and plug those values in to find x, the axis of symmetry. The opposite of b is -2 over 2 times a, which is 1. When I simplify, I see that my axis of symmetry is located at x equals -1. So this x value here is -1. Okay. I still need my y value though. Remember, to find your y value, once you know the x value of the vertex, you can go ahead and plug that value in for x to calculate your y value. So the y value of my vertex, or k, will be equal to 1 times x squared. So my x value is -1 plus 2 times -1 minus 3. I just plugged that x coordinate of the vertex in for x. I'm going to go ahead and solve that. So I've got, all right, -1 squared is 1 plus 2 times -1, that's -2. So 1 plus -2 is -1, and then minus 3 is -4. Okay. So that vertex is located at -1, -4. And remember, those are my h and k values. So now I can take those values and plug them in. Okay. So my final function in vertex form, well, a, remember, was 1, so that's going to stay 1. X minus h, okay, my x coordinate was -1. Remember, it's opposite what you would think. Right, so this is at +1, x plus 1 here. And then my y value was -4, so plus -4. Or -4 would work. All right, we're going to do the same thing for number 4. So the first thing we have to do to write it in vertex form is find the vertex by using that axis of symmetry formula. Okay. A is -2, B is -12, and C is -23. The opposite of B is +12 over 2 times -2. When I simplify, I get x equals -3 for the axis of symmetry. So my vertex has an x value of 3. We still need to find that y value though. So remember, we're going to take that x value and plug it in. Okay, so y is going to be equal to -2 times -3 squared minus 12 times -3 minus 23. Okay. And I get that y value is -5. So I'm ready now to use my vertex and my a value to write this in vertex form. Okay, so a, remember, was -2. That doesn't change. On the inside, my x value was -3, so I'm going to have x plus 3 inside, and then -5 because the y value of my vertex was -5.